Hello students, in this video we'll see an example of how to find the strike price of an option given information about its delta. Let's suppose a stock pays no dividends, has a price of 50 with risk neutral rate of return, .04, so 4% rate of return, that's risk neutral, and has volatility .2. Let's find the strike of a call if the delta of this call option is 1/2. So, to analyze this problem, we're given the delta of the call is 1/2. We also know the delta of a call is e to the negative delta t n of d1. And since there are no dividends, our delta is 0, so this becomes e to the 0 t n of d1. And then this is just n of d1. So if n of d1 is equal to 1/2, we know that d1 must be equal to 0, because the normal distribution is a symmetric distribution. Half the mass is to the left of the origin, half the mass is to the right of the origin. So when n of d1 is equal to 1/2, that must mean that d1 is equal to 0, the point of symmetry of the distribution. That tells me that n of d1 is equal to 0. Now we can continue the problem. So we know that d1 is the log of s over k plus r minus delta plus 1/2 sigma squared t all over sigma square root of t. And if it was at time t, I put a t minus t here. So we simplify this. We know that this has to be equal to 0. This is equal to 0, which tells me that the natural log of s over k plus r minus delta plus 1/2 sigma squared t is equal to 0. And now we can fill in information over here. So we know that delta is equal to 0. So we have that the log of s minus the log of k plus r plus 1/2 sigma squared t is equal to 0. And so let's specify that this will be a 1-year option. Let's suppose further that t is equal to 1. If t is equal to 1, we can solve for this. So we have that the log of k is the log of s plus r plus 1/2 sigma squared times 1. We could leave the t in there if we wanted to, just knowing that's 1. And then we can exponentiate this. So we have k is e to the log of s plus r plus 1/2 sigma squared t, which becomes s e to the r plus 1/2 sigma squared times t. And now we have all of our parameters. This will be the stock price, which is 50, e to the r, which we know to be 0.04, plus 1/2 times sigma squared, and sigma is 0.2, so then I'll have a 0.2 squared, and t is 1. So if we simplify this on the calculator, we'll find out exactly what the strike price is. So knowing the fact that the call option has a delta of 1/2 tells us that D1 is equal to 0. So knowing properties of the delta of the option allows us to compute properties of the cumulative distribution function of a normal distribution, and that oftentimes will unlock the problem. Thank you very much.